And in the previous class we talked about plane section of a sphere, which is nothing but whenever a sphere is intersected by a plane, the common part of the intersection is nothing but a circle. So yesterday we have seen what are the criteria so that the plane will intersect a sphere, and how to calculate the center and radius of this circle, that we have discussed earlier. So could you recollect those formulas? Because in today's session we are going to discuss about those concepts, problems based on that. All right. Now, if you consider that this is a sphere, say yes, then the plane what you are considering may cut at any part of the sphere, on the top, bottom, or in the middle. So whatever the portion it will consider to cut, obviously you will get a circle. So among all these circles, the largest circle is possible if the plane passes through the center of the sphere. Accepted? Are you getting the vision? Right. So if the plane passes through the center of the sphere, then the circle which is obtained there has the maximum radius. Such circle we call it as great circle. And if you consider any other circle apart from this, we call it as a small circle or simply circle. So whenever you say that the intersection is great circle, by default we need to understand that the plane is passing through the center of the sphere. Another formula what we are going to use here is, if S is the sphere, pi is the plane, S and pi will intersect, you will get a circle. So through this intersection you are going to find a new sphere. So what sphere we are calculating actually? This is the new sphere. If you say it contains the circle on it. So how this circle is formed? It is formed through the intersection of a sphere and a plane. So to evaluate this new sphere, the formula what we use is S plus lambda pi equal to 0. It is just like pi 1 plus lambda pi 2 equal to 0 of the planes. So lambda is the parameter which we are going to calculate as per the given condition of the problem. So what actually S plus lambda pi gives? It is used to evaluate a new sphere equation which contains the plane section, the circle. Okay? Are you clear? Right. And another thing, now just imagine if a sphere intersects another sphere, just like a sphere is overlapped on the other one, then what is the point, what is the common intersection for them? It is nothing but the circle again. So whenever a plane cuts the sphere, you will get a circle. Whenever a sphere intersects another sphere, you will get a circle. So again we use the same formula, S1 plus lambda S2 equal to 0, to evaluate a new sphere equation which passes through the circle of intersection. So these formulas are useful for the further problems. Okay, so please take a note of that. After noting, please tell. So the first problem is, find the radius and center of the circle find the center and radius of the circle Actually, the question will be asked as, find the radius and center of the circle formed by the sphere and the plane. But by default, whenever a sphere and plane are given to us, we have to understand that they will intersect, and the intersection is nothing but a circle. So what you are calculating here, you have to evaluate the radius and center of the circle which is formed by the intersection of these two. Okay, so let us imagine the picture one more time. So this is the given sphere and this is the plane given that, and the circle will be formed here, right? So from the given sphere equation, on observing that, can you tell its center, what it is actually? The center value? Center formula is minus u minus v minus w. Can you give that from the given sphere equation? Right, 0, 1, 2. Again, you calculate the radius of the sphere, which is nothing but square root of 0 square plus 1 square plus 2 square, and then minus of minus 11, nothing but 4. So here, while writing the sphere equation, you should take all the values to the left hand side. So D is nothing but minus 11 here. So whatever the equation it is given, we should write it in the proper manner, then only we solve the problem. Okay, so D is nothing but minus 11 here. But in the problem, the constant is given in the right hand side in the sphere equation. So we need to write in the proper manner. So radius is nothing but 4. I have given the formula to calculate the circle radius. What it is? Circle radius whole square is equal to sphere radius whole square minus distance whole square. Can you imagine that formula? What I mentioned earlier? This is the thing actually we do. So this part is nothing but the circle radius. You will have a right angle triangle here. This is the distance and this is nothing but the sphere radius. Right. So let us calculate the distance. How we are calculating the distance? The distance is calculated from center of the sphere to the plane. So distance, the formula is ax1 plus by1 plus cz1 plus d by square root of a square plus b square plus c square. So here in the plane equation also, it is considered as x plus 2y plus 2z minus 15 equal to 0. This is our plane equation. So if you take ABCD values, A is 1, B is 2, C is 2 and D is minus 15. X1, Y1, Z1 is nothing but 0, 1, 2. So could you tell me the value, the distance value here? Three. So substituting the values there, you have that circle radius whole square is equal to sphere radius whole square minus distance whole square, nothing but 16 minus 9. So we have 7. Therefore, circle radius is nothing but root 7. Are you clear with it? The procedure part? Right. Now, the second thing is we have to calculate the center of the circle. Here, center is nothing but the foot of the perpendicular which is on the plane. So you are calculating the foot of the perpendicular from center to plane. So if you write the perpendicular line equation, let us say C is the center of the sphere, M is the foot of the perpendicular. So if you want to write the equation of the perpendicular line CM, it is nothing but x minus 0 by 1, y minus 1 by 2, z minus 2 by 2. So the denominator values are nothing but the plane drs. In the numerator, I have taken the center values. So if you consider the parametric form for it, you have that x is equal to r, y is equal to 2r plus 1, z is equal to 2r plus 2. So any point on this perpendicular line will be of this form for some r. So foot of the perpendicular is also of the same form for some r. Since the foot lies on the plane, if you substitute these values in the plane equation, you will get the value of r. So here r will be equal to 1. If you substitute x, y, z values in the plane equation, you will get the value of r equal to 1. Substituting r value here, the foot is nothing but 1, 3, 4, which is nothing but the center of the circle. You can check whether r is equal to 1 or not by substituting the values in the plane equation. Please confirm your work. Then I will take the other model. That's what I am saying. This is the plane. M is the foot. So M lies on the plane, isn't it? So if you substitute different values of r here, you will get different points. So M is also of the same pattern. So substitute these values in the plane equation so that you can get the value of r. Because M is lying on the perpendicular line and also the plane. So once you finished with finding the value of r, you please confirm, then I will take the other model. Find the equation of the sphere through the circle x x square plus y square plus z square equal to 9, comma, two x plus 3y plus 4z equal to 5, and the point 1, 2, 3. So after noting this problem, can you tell what formula we have to use here? As per today's class discussion. So here we have to use the formula s plus lambda pi equal to 0, where s stands for the given sphere, pi stands for the given plane, lambda will be the parameter which is needed to be found. So substituting the values here, x square plus y square plus z square minus 9 plus lambda into 2x plus 3y plus 4z minus 5 equal to 0. So here you are calculating a new sphere equation which is passing through the circle. The circle is nothing but the intersection of these two, and also the new sphere passes through this point. If you want a small visualization, you can imagine that this is our required sphere having two properties. One property, it contains the point 1, 2, 3. Other property, it contains the circle. This you can imagine for your understanding. So in order to evaluate lambda, substitute the point 1, 2, 3 in place of x, y, z there. Then you will get that the value of lambda equal to minus 1 by 3. So substituting lambda there, you will get the required sphere equation as 3x square plus 3y square plus 3z square and minus 2x minus 3y minus 4z minus 22 equal to 0. That you can check. So please take a note of the solution. If any doubts, you can ask. So can I take the other problem? Right. So I am skipping the part of simplifying the terms. The equations I am not simplifying. I am giving the approach how to solve it. Is it comfortable for you? Right? Now, this model is important with regard to the exam point of view. The question tag is very similar. Find the equation of sphere through the circle x square plus y square plus z square equal to 5 and x plus 2y plus 3z equal to 3 and touch the plane four x plus 3y is equal to 15. So this kind of problem you can expect in the exam point of view. The question is very similar to the previous problem. The same formula we are going to use here, but the determination of lambda is different here. So if you visualize the thing, what we need to calculate, we have to evaluate the sphere. Let us say this is our required sphere. So it has two properties. It contains the circle given by the sphere and plane. So it has the circle on it, and it will touch the plane which is given there. So it touches the plane. Now, what could we expect so that a sphere will touch the plane? What are the checking condition? That also I have specified earlier in the previous class. So for intersection, radius, distance, if you compare, distance must be less than radius. But for just the touch, distance and radius both must be equal. Just imagine that if this is the center of our required sphere, you can observe that radius and distance both are same here. Accepted? Yes or no? Right. So if you say that the sphere and plane just touch, then R is equal to D. Intersect, then you say that distance is less than radius. So as usual, the procedure is very common. To evaluate lambda, we check this condition. But formula is very same. So let us use the formula S plus lambda pi equal to 0, which is x square plus y square plus z square minus 5 plus lambda into x plus 2y plus 3z minus 3 is equal to 0. So if you simplify the terms, it will come as x square plus y square plus z square plus lambda x plus 2 lambda y plus 3 lambda z minus 5 minus 3 lambda equal to 0, or you can say minus of 5 plus 3 lambda equal to 0. That was the thing. Now first we calculate the center. So center is nothing but minus u minus v minus w, center formula. So if you observe that it is nothing but minus lambda minus 3 lambda by 2, minus lambda by 2 minus lambda minus 3 lambda by 2. Accepted? And radius, if we calculate, square root of lambda square by 4 plus lambda square plus 9 lambda square by 4 plus 5 plus 3 lambda. So you can take LCM 4 there. So 4 comes outside. So it will be 1 by 2 into square root of 14 lambda square plus 12 lambda plus 20. If you go for LCM in the numerator. So this is all about the radius. Now we need to calculate the distance. So you are calculating the distance from center to given plane. So obviously the distance formula is modulus of ax1 plus by1 plus cz1 plus d by square root of a square plus b square plus c square. Substituting the values there, it will be modulus of 1 into minus lambda by 2 plus 2 into minus lambda and 3 into minus 3 lambda by 2 plus d is nothing but Just hold on a second. The distance from center of the sphere to the plane is the, but we need to consider this plane, the problem plane. So you have modulus of 4 into minus lambda by 2 plus 3 into minus lambda minus 15, where everything will be 0, by square root of a square plus b square plus c square, nothing but 16 plus 9. That was the thing. So you are calculating the distance from center of the sphere to the new plane, where the sphere touching the plane, that we consider. So if you simplify this, you will get it as so I have equated both distance and radius. So 5 gets cancelled here. You can do cross multiplication and squaring on both sides. On simplifying, you will get a good equation in lambda. After simplifying the part, you will get the equation as 5 lambda square minus 6 lambda minus 8 equal to 0. So doing squaring on both sides and simplifying, you will get that equation. So which gives that lambda equal to 2 and minus 4 by 5. So here what happens, you will get two sphere equations. By substituting lambda is equal to 2, you will get one sphere. By substituting lambda is equal to minus 4 by 5, you will get the other sphere. So please take a note of this, then I will write the sphere equations. You can cross verify the answer. So if you ask me the values of that, so these are the two sphere equations which we will get by substituting lambda is equal to 2 and as well as minus 4 by 5. So please check the approach. If you have any other queries, you can ask with regard to the procedure. Otherwise, I will take the next model. So let us take the other one. Find the equations of spheres passing through the circle x square plus y square plus z square equal to 4, comma z equal to 0, and is intersected by the plane x plus 2y plus 2z equal to 0 in a circle of radius 3. So it is also an interesting model. It is also given in one of the previous papers. So please take a note of that. So for the last sum, I will say, can I dictate or can I write? Okay, I will write. X square plus y square plus z square this is one equation. The other one is that is the other one. Yes, definitely. Let us take xy plane. Is it a plane or not? The coordinate planes, if you consider. So the equation of xy plane is nothing but z equal to 0. So obviously you can take z equal to 0 as a plane. The better thing is nothing but visualization. So if you observe the sphere equation, it is nothing but the sphere having center origin and radius 2, and if the z-axis, if the xy plane intersects the sphere, then you will get a circle. So through that circle, you are going to calculate a new sphere, and if the new sphere is intersected by the plane, the circle radius will be 3. That was the whole concept. Can you visualize that? Yeah. Now, the procedure is very similar. The same formula we are going to use. So first of all, a circle is given. This is our circle. So first we calculate the sphere equation using s plus lambda pi equal to 0. So the required sphere is x square plus y square plus z square minus 4 plus lambda into z equal to 0. So which is nothing but x square plus y square plus z square plus lambda z minus 4 equal to 0. So if you determine lambda, the suitable lambda value as per the problem condition, then you are done. So for small visualization, you can draw the picture like that. This is our required sphere, and which contains the circle as per the problem. And if the new sphere is intersected by this plane, say this is the plane which intersects, then you have a circle here. This circle has radius 3. It is given in the problem. So you will have a right angle triangle here. So is it comfortable to visualize the diagram? Right. All of you. So whenever the circle of intersection is appeared here, by default we use the formula that circle radius whole square plus distance whole square is equal to sphere radius whole square, the Pythagoras formula. Side square plus side square is equal to hypotenuse square. So from this new sphere, let us calculate the center as well as the radius. So center is nothing but 0, 0 minus lambda by 2, and radius is nothing but square root of lambda square by 4 plus 4. Accepted? Right. Then if you calculate the distance from center of the sphere to this plane, so it is nothing but 1 into 0 plus 2 into 0 plus 2 into minus lambda by 2 by square root of 1 square plus 2 square plus 2 square. This is nothing but the distance. So distance, if you simplify, nothing but lambda by 3. So this is equal to modulus of lambda by 3 you take. Substitute the values here. Circle radius is given that 3. So 3 square. Distance, if you square that, lambda square by 9 is equal to sphere radius, if you square that, lambda square by 4 plus 4. So if you simplify that, lambda square is equal to 36, lambda is equal to plus or minus 6. So lambda value, you will get it as plus or minus 6. Please check on that. So the required sphere equation is nothing but x square plus y square plus z square plus or minus 6z minus 4 equal to 0. That was the solution. So the best thing in solid geometry is reading the question one after the other and line by line. And if you frame the suitable formula, the answer will come in an easy manner. Nothing difficult at all. It just includes the calculation part. That's it. So is the solution part clear to all? Then I will take the next concept. Show that the circles please take a note of this problem. So here it was asked that show that the circles will lie on the same sphere. In other words, if you are able to calculate a sphere equation which contains the two circles, then you are done. That was the objective of the question. So the approach here is, I will consider a sphere which passes through first circle, say s plus lambda pi equal to 0. Also, I will consider a sphere which passes through the second circle. Let us say s plus mu pi equal to 0. If the two circles belong to only one sphere, then these two are nothing but the same equations. Accepted? So the technique here is, I will apply s plus lambda pi equal to 0 and s plus mu pi equal to 0 for these separately, and I will equate the respective coefficients. So by determining lambda and mu, I will get a single speed equation which gives the required result. So it is nothing but from the first one, by taking the terms common, I will write x square plus y square plus z square plus lambda x plus minus 1 minus lambda into y plus 2 plus lambda into z minus 2 lambda equal to 0. This is the sphere passing through circle 1. If you take the second one, x square plus y square plus z square plus 1 plus 2 lambda into x plus minus 3 minus lambda into y plus 1 plus 4 lambda into z minus 5 minus lambda equal to 0. So here we need to understand that if both the spheres are same, then you need to equate all the four things: x coefficient, y coefficient, z coefficient and constants also. So if you equate them, you have, since I have used mu here, I will write mu so lambda is equal to 1 plus 2 mu minus 1 minus lambda is equal to minus 3 minus mu, 2 plus lambda is equal to 1 plus 4 mu, and also minus 2 lambda is equal to minus 5 minus mu. So solving these equations, any two you can take, you will get that lambda is equal to 3 and mu is equal to 1. So if you substitute lambda value here, you will get a mu value obviously. Hence, the required speed equation will be x square plus y square plus z square. You can substitute any one of the values, either lambda or mu. This is the required speed equation. Please check and confirm the result. So I think if you do simultaneously with me, then it will be very easy for you to get the concept. Now this problem is interesting. Show that the 4 points minus 852, minus 522, minus 766 and minus 436. Are concyclic. So do you know the definition of concyclic? So concyclic is nothing but if all the 4 points belong to one circle. This is the picture. So if all the 4 points lie on a single circle, that we call it as concyclic. Now the thing is how to show that. The procedure is a little lengthy, but the logic is very easy. How to show that they are concyclic? And please understand that if they lie on a circle means the circle should be formed by means of a sphere and plane, because we are not separately finding a circle equation. Whenever the word circle appears, we need to understand that it is the intersection of a sphere and a plane. So how to prove that they are concyclic? Okay, find a center. So center of what? Sphere. Then how to determine the sphere here? So if you want to use S plus lambda pi, a sphere equation must be there, a plane equation must be there, but they are not given actually in that. That's a good one. So with the 4 points, we can calculate sphere equation. That very nice. Then all the 4 points will lie on a sphere. That's nice. Then you have arrived 75% of the problem. Just 25% remained there. I will give the small idea. One of our friends told that using the 4 points, we should find a sphere. That is perfect. Then what we have to do? Exactly. So using the 4 points, you should find a plane. So on the whole, what you are doing, we need to calculate a sphere equation and a plane equation. So how the sphere will be determined? Using the 4 points, we should calculate a sphere. Using the 4 points, we should calculate a plane. In other words, we are finding a sphere satisfied by the 4 points. We are finding a plane satisfied the 4 points. So it is nothing but the 4 points are common for the sphere as well as the plane. So obviously you have specified that these two are intersecting. That intersection is by default a circle, as we know. Fine. That is the whole idea. So how to find? So among the 4 points, let us consider any 3. When 3 points are given, you know how to find the plane equation. You have a formula. Determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1 and z3 minus z1 equal to 0. You can consider any 3 points. So this is x1 y1 z1, x2 y2 z2 and x3 y3 z3. So if you substitute the values here, I will take one more step. So x plus 8, y minus 5, z minus 2, then you have 3, minus 3, 0 and 1, 1, 4 equal to 0. So if you simplify that, the plane equation, you are going to get it as 2x plus 2y minus z plus 10 equal to 0. By substituting the 4th point here, you have found a plane which is satisfied by the 4 points. Clear to all? right? Now, to determine the sphere equation, here we can follow two things. The first method is let us consider the general equation of the sphere. Now you substitute the 4 points one after the other here. You will get 4 equations. Solving them, you will get the values of u, v, w and d. That is the usual method. So substitution takes a time. Solving 4 equations will also take a time. If you convert them in the matrix form, the equations, the form of Ax is equal to b, to determine u, v, w and d values, that is fine. The second method we can do is, let us assume that the sphere passes through origin. So what happens? In order to determine a sphere equation, we require 4 points. We are choosing the sphere in such a way that it passes through the first 3 points and also origin. So what happens? Evaluation of one parameter will be reduced. So there is no need to calculate the constant d. That we can avoid. So if you substitute the 3 points in the sphere equation, then you will get the respective equations as so these are somehow little big equations. So on solving them, you will get the values as u is equal to minus 11 by 8, v is equal to minus 91 by 8, and w equals to minus 5 by 16 on solving the equations. So we substitute the first 3 points, minus 852, minus 522, minus 766 in the general equation of the sphere. If you say the plane equation is not satisfying that, it is not satisfying any point, you mean the 4th point is not at all satisfied, maybe the answer is somewhat wrong, you can do this. So if you have a doubt, you remove this point, you consider the 4th point, then calculate the plane equation. Because you can determine the plane equation by using any 3 points. Why should we stick on to the first 3? You can take 1, 2 and last. Then you can find the plane equation, right? Then 3rd point will be satisfied automatically. That you do right now. So it is not satisfying any point, maybe I have taken the equation as wrong. But you can find it, the plane equation. So can you calculate the plane equation right now? If you don't mind. By applying this determinant formula, you can take any 3 points of that and please give me the plane equation. So 2x plus 2y minus z equal to 8. All right. Then the 4th point will be satisfied, accepted, right? that you can take. So the sphere equation, which you will get it as eight into x square plus y square plus z square minus 22x minus 182y minus 5z equal to 0. So you can check that the fourth point minus 436 will be satisfied by the sphere equation. Yeah, I will repeat that. I am saying that we will assume that. See, in the space, you can form infinite number of spheres, right? You cannot fix that there is only one sphere passing through the 4 points, isn't it? There may be so many spheres passing through the 4 points. By different rotations, you can calculate different spheres passing through the 4 points, isn't it? So, if you didn't agree with that logic, then we go with the usual procedure. What we will do? Straight away, you take the constant also, the general equation of the sphere. Then what happens? If you substitute the values there, obviously you will get d here. Then you substitute the fourth point also, you will get one more equation here and having d. Now you solve these two. The thing is, you need to evaluate so many parameters here, which takes the computation time more. So for this, the best approach is, you can convert this into a matrix form. X is equal to B, the non-homogeneous form. The variables are nothing but U, V, W, D. So you convert this into echelon form by applying row operations. Hence, by back substitution, you can determine all the values. So it is not mandatory to assume that the sphere is passing through origin. By assuming that it passes through origin, computation will be easy. Yes, that is also right. That's why I mentioned that without having any dilemma, just solve the 4 equations by substituting the fourth point also. That's what I said. Here the interesting thing is, plane is important apart from the sphere. So the interesting thing, here you have calculated the plane using the first 3 points. See, if you say that A, B, C are the 3 points there, you have calculated a plane passing through the 3 points and satisfied whether the fourth one is there or not. If you want to calculate the sphere equation, in that case also, we take origin and ABC. But we are not taking origin A, B, D, then obviously it is wrong. So by taking itself that A, B, C are common to plane and sphere, you have done 90% intersection there for both of them. So for majority of the cases, the fourth point will lie on the sphere as well as the plane. So whatever the 3 points you are using to calculate the plane equation, those 3 points we are using to calculate the sphere equation and including origin. So assuming origin is also right. That is also one method. So you have 2 things. If you have any doubt, you substitute all the 4 points in the general equation, evaluate all the 4 values. The thing I can say, you can have a small visualization like this. if you say that in the 3D space, let us assume that this is the plane which contains the 4 points. Say, now you are calculating a sphere having the 4 points, so you can do the thing like this. A sphere which is not passing through origin and a sphere which passes through origin, that also you can do, right? A small sphere you can consider which also passes through origin. The same plane will come. You can see the difference. So assuming that the sphere passes through origin is just like a shortcut. For majority of the cases, the solution comes correctly. So if you want the exact one, you need to calculate the sphere equation substituting all the 4 points. Okay. So you have the concept of consecutive is clear, right? You are finding a sphere equation as well as plane equation satisfied by the 4 points. That is actually you are doing. Since the 4 points are satisfied by both sphere and plane, they will form the intersection, which is nothing but a circle. So any confusion or any doubts for anybody on this point? Why we are using origin such that the sphere is passing through it? So I feel that you are calculating a big sphere and a small sphere having different radii, so that the two spheres will touch the 4 points. That is my understanding. So can I take the other one? So this is the problem. So this is the problem. Please take a note of it. Right. So here it is given that if you consider a variable plane, the plane which is moving in the space, and the variable plane is parallel to this one. This is a plane passing through the origin. And the variable plane intersects the axis in A, B, C points respectively. So you will get a circle which passes through the points A, B, C. So you have to show that the circle satisfies the equation. That was the objective of the question. Okay. So since the plane is parallel to this one, whenever you consider the parallel planes, x, y, z coefficients are same and they only differ in the constant. Agreed? You consider parallel lines as well as parallel planes. Both will have the same coefficients, only constants will vary. So let us take that the variable plane is nothing but x by a plus y by b plus z by c is equal to some constant we should take here. I am taking the constant as lambda. So this is the plane which is parallel to this one, and I have assumed that this is the variable plane. Accepted to all? So if you convert that into intercept form, nothing but dividing with lambda, it is x by lambda a plus y by lambda b plus z by lambda c is equal to 1. So this is the intercept form for the variable plane. So at this point you can say x intercept is lambda a 0 0, y intercept is 0, lambda b 0, and z intercept is 0 0 lambda c. As per the problem, they are nothing but the points a, b, c respectively. Any questions to anyone still at this point? Right. Understand that this is the circle. So here we need to understand that the circle is formed by the intersection of a plane and sphere. So obviously you have calculated a plane which passes through the points A, B and C. Now I want to calculate a sphere which passes through the points A, B, C. So I take the fourth point by default as origin. So I will take that the sphere equation passing through the 4 points origin A, B, C. Since the fourth point is not specified in the problem, so I am taking the fourth point as origin here for computational convenience. So straight away what happens, whenever the intercepts are there, origin is there, I have given a general notation of this sphere formula. The sphere equation is nothing but x square plus y square plus z square minus lambda ax minus lambda by minus lambda cz equal to 0. Can you imagine the form? Right. Now here my intention is I want to eliminate lambda here. In other words, I need to calculate a value for lambda. So in the sphere equation, you can do the further modification as so obviously in the variable plane, lambda is nothing but x by a plus y by b plus z by c. Straight away substitute the value there. So if you multiply with that number, x square, y square, z square gets cancelled and the required locus will come. It's a simple problem. Since it is given that the variable plane is parallel to another plane, you have taken the parallel plane equation. So from that parallel plane, you have considered the intercepts. Using intercepts, you have written the sphere equation. In the sphere equation, you substituted the lambda value, then you have achieved the required locus. That is the overall idea. Okay. So please check with the simplification. You will get the same locus which is given there. So then let us conclude our today's session here. We will meet tomorrow with the other concepts. And thanks for you.